Okay, so here we go. Go to page 1 of 1. We're looking at forces. We're looking at forces. I need you to read it out. Go ahead and read it out now. Forces. Anyways, we have two types of forces. There's contact force. There's non-contact force. All right. So contact. Two objects must touch. So you have friction. You have air resistance. You have push, pull, tension, and compression. By the way, all of these forces will require two objects touching. To stretch, you need to hold to an object and stretch it, isn't it? Mm-hmm. To compress, you need to hold the thing and squash. By the way, compression is squashing. Tension is stretching. They are all called contact forces. Then we have non-contact forces. Can you give me examples of non-contact forces?
Okay. Gravitational force.
You have magnetic force, gravitational force, electrostatic force as non-contact forces. They are also called field forces because they don't require objects to actually make contact. For instance, when you have gravitational force, what's even gravitational force? The force that pulls an object to the center of the earth. Now, do you see the earth actually holding the object and dragging it down? Yes. Do you really see the earth holding the object and dragging it down? Oh. But the force still acts. You don't see the earth holding. They are not really making contact. They don't have to make contact for the force to act. The same with magnetic force. In fact, when you bring two magnets close to each other, you experience a force. Or you bring a magnet and a magnetic material like an iron, a piece of iron, a steel, or other magnetic materials, nickel, cobalt. They experience a force which could be attraction for magnetic materials or even repulsion with another magnet. But then, those two magnets don't have to touch. Do you get that?
Okay.
So they are non-contact. So what are the two types of forces again?
Contact and non-contact.
What's another name for non-contact force? I mentioned it earlier.
But you said field.
Beautiful. You remember, that's cool. Field force. Okay, non-contact force is also called field force. Let me just note it down. Alright, field force. Let me zoom in to 100% so that this will come out better. So, examples of contact forces, can you mention them?
Examples of contact forces: friction, air resistance, tension, compression.
Excuse me. All right. So you have friction for contact force. Mention again other examples. Mention other examples of contact forces.
Compression, push, pull.
All right.
Friction, tension, air resistance.
Okay. Examples of non-contact forces or field force. Gravitational, magnetic, electrostatic, and so on. Okay, remember, non-contact force is also called what?
Non-contact force is also called field force.
Field force, okay. All right, let's look at some of the things that will happen when a force acts, what we call effects of forces. Effects of forces. So, when a force is acting on an object, it can cause the object to change its shape. It could squash, stretch, bend, twist. So the object changes its shape. This is one of the effects of forces. Another effect is it can make an object change its direction if the object was already moving. Imagine you kick a football and it's moving in this direction towards you. Are you getting what I'm saying?
Yeah.
And then you have to apply a force by kicking the football and from your end. It can change the direction of the football, maybe to the right, or back to me, or even to the left. So you can make an object change its direction, you can make an object change its shape, you can make an object change its speed. An object can move faster by applying a force on it, or even slow down. Did you get that?
Yes, sir.
That's basically what we call change of motion. So what are the effects of forces again?
It changes motion. Wait, what?
Go ahead.
Change of shape, change of direction, change of speed, or change of motion.
Okay, so change of shape, change of direction, change of speed, or change of motion. Now, this what we call, this one is very important, resultant force. Balanced and unbalanced forces. Okay, you see, forces are balanced if they don't produce a resultant force. Look at this one I have here.
But that's supposed to do the work.
No, before you do the work,
I've already started.
I told you something about balanced forces. Before you start, watch this. I said forces are balanced if there is no resultant force. Are you on page 2 of 7?
Yes, sir.
What's the resultant force of this one I'm circling?
0.
Because you have 20 Newton to the right and 20 Newton to the left.
That's
It's
because
subtract.
yeah.
So once there is no resultant force, the forces are balanced. Now I need you to take note of this. When the resultant force is 0, the object will either remain at rest
I know, or contact speed.
or move at a constant speed. So when the forces are balanced, the object will either stay. Are these forces balanced?
No.
They're not balanced. What's the resultant force?
20.
Now when you state a force, you need to mention its
20
direction.
Newton. I know. That was that.
20 Newton to,
The right.
because the bigger one is.
Going to the right. I know.
So since they are not balanced, the object will not move at a constant speed. Did you get that?
Yes, sir.
The object will not do what?
Move with the contact
So
speed.
the object will either move faster. Look at what I'm circling here. When an object moves faster, we say it accelerates. Or the object will slow down, we say it decelerates. That's when the forces are not balanced, or when they are balanced. Is it when the forces are balanced or when they are not balanced that the object will either accelerate or decelerate?
It's when they are. Wait.
When they are not balanced, of course. When they are not balanced, that's when the object will not move at a constant speed. The object will either speed up or slow down. Okay?
I have a question.
Okay. First of all, before you go, I want to listen to your question.
Yes. Does friction help the object to move faster, or it slows it down too?
Usually, friction slows down motion.
But is friction always helpful?
It can be helpful. Friction can be helpful.
Always or never?
It's not always. But then, this could be part of the question I want you to answer. All right, so let's go on. Before you ask those other questions, let's look at this. When they are balanced, the forces cancel out each other, the forces cancel each other out, and the car will continue to move at what?
Contact speed. A steady velocity.
Or which is also called constant speed or velocity, if you like. The resultant force at that point will be what?
0 Newton.
Okay, so let's look at another one. So they are not balanced. Since they are not balanced, what happens?
It goes to the right.
It speeds up to the right. Right? So let's look at this final one. Initially, this object was moving this way. Please, you need to see what I'm drawing. This object was moving this way. The blue shows us the direction of the motion. So the forward force in the direction of the motion is 200. The one opposite the direction of motion is bigger.
So then what's that
So
position?
it will slow down. It will slow down.
But what's that position?
Position?
Yeah.
No, it's part of the question you need to answer. So we'll go to it. So we go to the question now. Let me even see how many you've done already. The question says, indicate if the statement is true or false. When a force is balanced, I will be marking it as I work solving it. When a force is balanced, there is no change in motion. What did you write? Number 1. Say it out.
I wrote true, false.
When a force is balanced, there's no change in motion. That is true now. When it's balanced, there's no change in motion. So that's actually true. It should be true now. Because if it is balanced, there's no change in motion, the object will be at rest.
Wait, it says
when a force is balanced, there's no change in motion. The object will stay at rest, or if it was already moving, the object will move at a constant speed or steady speed. So no change in motion. Change in motion means it will not slow down, it will not speed up. All right, let's go to the next one. Okay, let me see. Go to the next page. Go to the next one. Gravity is a force that pushes objects down to the earth. That's correct, it's true. Force is a push or a pull. Force is a push or a pull. That's correct. Friction helps objects move faster. Does friction help object to move faster?
Nope.
But you wrote true. It doesn't help object to move faster. I told you it usually slows an object down. Slows down a moving object. Number 5, friction is always helpful. So you were asked, you were deliberately asking me to reveal the answers to you.
No.
Friction is not always helpful.
Okay,
no. Okay, so that's correct. Friction is not always helpful. So it's false. Balanced forces do not cause a change in direction. Is it true or false?
What? It's false.
I'm reading number 6.
True.
Balanced forces do not cause a change in direction.
False.
You're confused? No. Let's be sure.
Which number?
Number 6. Balanced forces do not cause a change in direction.
True.
True or false?
True.
True. Which one causes a change in direction?
Unbalanced force.
Unbalanced forces cause a change in direction. Balanced forces do not cause a change in direction, because when the forces are balanced, the object will stay at rest if it was already at rest, or it will move at a constant speed if it was already moving. So no change in direction, no change in speed. You move this, okay. The amount of space between two objects or places is called position. The amount of space, like from where you are to where I am.
It's not.
What should it be? From where you are to where I am, should be what?
I don't know. What? Position.
Position can not be the space between.
No, that's not what position is. Position
Is
is
your location.
still in my spotlight.
Okay, so go ahead.
Professor.
You're a professor, I know.
Now, position is where the object is at a particular time or moment.
Beautiful.
So
It cannot be the space between them. So I think you are right. So, but what do you think is the space between two objects?
I don't know.
That should be distance. The space between, like where you are from where I am, is the distance between the two of us. Okay, you're making progress. How many do you have left? Still a lot to 17. Okay. A force that makes an object move is a push or a pull. Yes, we can take that. A swing moving back and forth is an example of motion. That's true. A force can change an object's motion. Number 10. You don't answer that one. A force can change an object's motion. What do you think?
False.
A force can change an object's motion. Write it in full now so that I'll be sure of what you wrote. For number 10. Anyways, what can you remember again or remind me about the effects of forces?
Force changes motion.
What are the effects of forces? It's on page 1. Oh, that's the first thing we.
I know the effects of forces. It changes your speed, changes motion, changes shape, and something.
Changes direction. Okay, and then the question is asking that. What was the question again? That's number 10, am I right?
Yes, sir.
It says.
I put true.
But remember, you put something before.
No, that was a mistake. I was trying to write for number 11.
Okay, so a force can change an object's motion. Is it true or false?
True.
So your final answer is true. Okay, so you have it. The object that pulls objects toward earth is called friction. Is it called friction? I'm talking about number 11.
I put force. No.
But what is it really called?
Gravity.
Gravitational force. So it's not called friction. It's force. Speed is calculated during the distance, using the distance traveled over the time it takes to travel. That's
Yes.
correct. Speed is distance over time. One way to measure distance is by temperature. It's force. Show me one unit you can use to measure distance.
What?
One unit you can use to measure distance.
Distance.
Mhm.
Kilometer per hour.
No, just kilometers, meter, centimeters, and what have you. Kilometer per hour is actually a unit for speed.
I know. Mix.
The meter per second is also a unit for speed. Okay, number 14. They're making progress. An unbalanced force in a game of tug of war will cause one team to lose. Is it true or false?
It's true.
If the forces are balanced, what happens in a tug of war?
To be equal, but someone still losing.
No. If the forces are balanced,
The other should stay at rest.
the object will stay at rest. So no team wins. No team pulls the other team to their direction. So I think number 14, you got it. That's true. 15. Motion is required to move an object.
No.
True or false?
False.
Motion is required to move an object. Alright. So heavier objects require less force to move. Force. Heavier objects will require more force, isn't it?
Yes.
Finally, 17. That is on for this page. An unbalanced force will cause an object to speed up, slow down, or change direction. Is it true? What about balanced forces?
Balanced forces. It allows it to stay still.
Stay at rest,
Yeah.
or balanced forces will make the object stay at rest if the object was already at rest,
Yeah.
or the object will be moving at a constant speed if it was already moving.
Yeah.
Okay, go to the next page. You were asked to turn over. This one is for the boys. You better get ready for it. Have you started already? On the next page. Are you on the next page?
Yes. My laptop is just reloading.
Okay, let's be fast about it so that you can do something else. Are you ready there now?
Yeah, it's I've entered now.
Okay. A force that tries to slow things down when two things rub together. Friction, okay? Correct. A force from water that pushes things up.
Wait, this is from water.
A force from water that pushes things up.
Okay, well, I know that.
What was that?
I'm typing it.
Okay. There are some clues.
I can't wait. Where is the clues?
I'm not going to give you, but there are some clues.
I can't spell it too.
Just write it down. Let me see what you can write down. A force from water that pushes things up. That's I. Be fast though. Buoyant force can make an object flow. It's actually, you see, I just showed you a clue. It's actually.
Where?
Well, to an extent you are right, but you have an idea. It's called upthrust. Upthrust.
Oh, that rubbish. Oh, okay. That thing that says put rock inside. Oh.
It's upthrust.
That says put rock inside something water and
yeah, it's upthrust. I'm going to write it in green because I reveal the answer to you. Go to the next one because there are other things you need to answer. Forces that try. Okay, you've written it. So I'll mark it in green. A force that tries to slow things that are moving through air. What do we call that force?
What?
Do you have an idea? No, say it. I can write it out. Say it so that we can move faster.
I'm wait.
No. Say it this time. This time around, say it. A force that tries to slow things that are moving through air.
Wait. It can't be that. It can't be that. Wait. I have an idea.
I'm listening.
Resistance.
You have an idea, actually.
Wait.
You really do. I'm waiting.
Don't spoil it. Resistance. Something resistance.
You have an idea.
Wait. Air resistance.
No, cool. That's cool. Air resistance. There's another name for air resistance. That's cool. Another name for air resistance is drag. Is what?
Huh?
I said another name for air resistance is drag. So you are right. The answer is air resistance. What does another name for air resistance is?
Drag.
Drag. D-R-A-G-E. Oh no, D-R-A-G. Or drag. Okay. Not moving means what?
Unbalanced.
No, what does not moving? When we say something is not moving, use another word for it.
Still.
Rest. At rest. No prompt.
Stationary.
Stationary or rest. You can use the word stationary. So I'll mark it for you. So that we can work faster. I'll have to be. When two forces working in opposite directions are not the same strength. Have you read this one?
Which one?
When two forces working in the same. When two forces working in opposite directions are not the same. When they are not the same strength. That's unbalanced force now. You didn't take note of that.
Which one?
I'm talking about, it should be VI. When two forces working in opposite directions are not the same.
Why is my F not working?
Okay, this should be unbalanced force.
Wait, it's working. Just not press it.
The amount of force on something from gravity, it is measured in Newton. Okay, the unit of force is Newton. You got this one. A push or a pull is a force. A piece of equipment containing spring that force. Force. No, it's not called force balance. A force gauge. You can call spring balance or force meter.
But they said we can also call this force gauge.
Okay. Use a term that is familiar. This is spring balance or. I'll mark it for you. Is this all? Okay, they can attract or repel each other. They also attract things made of iron. Have you answered this last one?
No.
We're almost done now.
I don't know what it is.
It's a magnet, of course.
How does magnet relate?
It can attract or repel each other. They also attract things made of iron.
Oh yeah.
How about this one? See the one I'm circling. The amount of force on something from gravity. It is measured in newtons. Oh, that's weight.
Wait. I said wait.
So that's weight. You got it.
Wait.
The force of attraction between two objects. The Earth has a large force of gravity which pulls things down towards it. I'm not sure you will know this one, so I will give it to you. It's actually called gravitational force.